Hey guys, today I wanted to review with you for our test tomorrow on matter. So as you can see, I'm on tysonpchs.weebly.com and I've gone to physical science course units and I've clicked on matter. Okay, that's where we are. So the first thing we're going to do is on this test, there's a few things that we need to talk about. We need to talk about the phases of matter and how they compare to each other with their particle movement. And we also need to talk about heating and cooling curves as well as um, gas laws. So the first thing I want you to do is go back and watch this video right here. That'll give you a good summary. Then remember, we've got our solid, our liquid, and our gas. And notice all the particles look the same. All of them are the same size, same shape, same mass. None of that changes as we go from a solid to a liquid to a gas. It's a physical change, so all that's changing is the space between them. So remember, nothing is changing about the particles themselves, just how much energy those particles have. So as we go from a solid to a liquid to a gas, we don't see any change in the size, shape, and mass of the particles, just how much energy they have. All right, so I've got a few videos I want you to keep reviewing. Remember, we talked about plasma was the most common state of matter in the universe. So go back and watch this video if you haven't. Okay. And chemical and physical changes. Remember, we talked about a physical change can be reversed. It's a change that we can undo. And chemical changes cannot be undone, like a rotting banana, rust, things that can be undone. All right. The kinetic molecular theory. This just says that all particles are in motion at all times, which means even though a solid doesn't have very much motion, they are vibrating tightly together. And the gas, we know, out of those three states of matter has the most energy, and plasma is above that with even more. But we know that all particles are in motion at all times. Even though solid has the least amount of energy, we know that they are still moving just a little bit. So, pressure, temperature, and volume, our gas laws. Remember what we talked about with pressure, temperature, and volume. You have your popsicle stick. If you haven't watched this video, go ahead and watch it. It's a really good overview. But remember, with our popsicle stick, we saw that pressure and volume were on opposite ends. So when pressure goes up, volume goes down. That's inversely proportional. And remember, temperature and pressure are a little bit different. When temperature goes up, pressure goes up. That means they are proportional. So if we look at this gas law simulator, kind of like we did in class, we can see a few really important relationships. So the first thing you see is if we lock volume, we just said when temperature goes up, pressure goes up. So when I heat things up, my pressure goes up. Why? Because the particles have more energy and they're hitting the walls more often. Okay, let's say I want to decrease the volume. We know that's going to make pressure go up. So we decrease the volume, we see pressure going up. Why? Because there's less space for these particles to move. And the more they hit the walls of the container, the higher that pressure is. So go ahead and go back and play around with this. Look at your popsicle stick, watch the video. This is the lab we did in class. And the last thing I want to tell you is, I know this video is kind of dry, but go ahead and watch it or watch my lesson on heating and cooling curves in Google Classroom, because we need to understand that as we move from a solid to a liquid to a gas, heat energy is increasing. As we go from a gas to a liquid to a solid, heat energy is decreasing. Temperature is going down. And the particles are slowing down until they get to the lowest temperature and lowest heat energy. As we go from a solid to a liquid to a gas and heat energy increases, we see that we are absorbing energy. We're absorbing that heat. As we cool it down, we're releasing it. And don't forget, on the flat lines, that's where your phase change is happening. So we see two states of matter at once. We see some solid, some liquid. But remember, temperature is not changing here because we're right at our melting point. We're right at our freezing point. Things are changing, but temperatures staying the same. And here we heat it up, heat it up, heat it up, and we see we get to our boiling point, things are staying the same. So go ahead and review that. Read the parts under it where it says what the plateaus mean. The plateaus, the flat lines, are our phase changes. And the other lines are where we're heating up our state of matter. So we're one state of matter, then we get to our melting point, and we see two states of matter, our liquid, then we see two states of matter. We see some liquid, some gas. So I just want you to read through this. Be sure you understand what's going on these. Go back to your notes and look at them. And I will see you tomorrow.